Hello, today we are going to delve into Albert Einstein's theory of special relativity, so let's get started. It can be understood in simple terms like this: space and time are interconnected. Before the theory of special relativity, people believed that space and time were separate entities. Einstein changed this perception, showing that they are closely related. The moving star constellation. We imagine a constellation of fixed stars in space. Before Einstein, distances and time were thought to be absolute, meaning that for all observers the stars would move in the same way. Einstein said this is not true. Principle of relativity. He introduced the principle of relativity, which states that all physical laws are the same for all observers moving uniformly, regardless of their speed. In other words, if you are in a spaceship in uniform motion, the physics in the ship is the same as the physics in a stationary ship. Time dilation. One of the consequences of this theory is that time is not absolute. If you are moving at a very high speed, your time will pass more slowly compared to someone who is stationary. This phenomenon is called time dilation. Length contraction. Like time, the length of objects contracts in the direction of motion when you are moving very quickly relative to a stationary observer. The twin experiment. Imagine two identical twins, one stays on Earth and the other goes on a space journey at near light speed and then returns. According to the theory of special relativity, the twin who traveled in space will age less than the one on Earth. This is due to time dilation. Its time passes more slowly due to its high speed. GPS, the Global Positioning System (GPS), uses the theory of special relativity. GPS satellites travel at high speeds and are affected by time dilation. Without corrections based on relativity, GPS would have significant errors in determining position. Length contraction. Picture a spacecraft traveling at close to the speed of light. Because its longitude will contract in the direction of motion, the craft will appear shorter to an observer on Earth than it actually is. E equals mc2 mass energy equivalence. E equals mc squared is probably the best known equation in physics, and it was developed by Einstein in the framework of special relativity. This equation shows that mass m and energy E are equivalent and interconnected. In other words, a small amount of mass can be transformed into a very large amount of energy. This is the basis for understanding the workings of the atomic bomb and the energy released in nuclear reactions, no faster than light. The theory of special relativity claims that nothing can travel faster than light in a vacuum. As a particle with mass approaches the speed of light, the energy required to continue its acceleration increases greatly, approaching infinity. This makes reaching or exceeding the speed of light theoretically impossible. Space-time unification. The theory of special relativity shows us that space and time are interconnected in an entity called space-time. This is a fundamental concept that describes how objects and events move in the universe. The mass and energy of an entity determines how it curves space-time around it, creating what we call the gravitational force within general relativity, which is an extension of special theory.